If you move a conductor in a magnetic field, a voltage will be induced across that. This is called electromagnetic induction. So, we will try to experimentally explore this phenomena today. Here we have a coil which is some 3000 turns of wire and also have a permanent magnet. So, if you move this magnet into this, there is a relative movement between this coil and this magnetic field generated by this, and when I move this, there is supposed to be a voltage induced across this. The easiest way to look at that is connect an LED and see whether the LED is glowing when we move the magnet. So, let us try that first. So, we have connected an LED and now we will move the magnet into that, and you can see that LED is glowing whenever you move the magnet into that. The problem with this method is you do not get any quantitative information. You do not understand how much voltage is induced or what is the nature of the voltage induced and how it depends on the velocity of the magnet and all such things. So, let us try to make some quantitative measurements. So, for that we will connect this coil to the X-Spice kit. Again, to measure the voltage we will connect it between a ground terminal and the voltage measurement terminal A1. See, A1 is capable of measuring an induced voltage between -5 and +5 volts. So, once we make this connection, on the screen we have to display this A1. So, drag A1 to channel 1 and we can see there is no induced voltage here. But if you look at the screen now and take this magnet again, move into this, so you can see that trace is moving, but let us change the time scale a little bit and repeat it. You can see that there is a big induced voltage, but again it is very difficult to find out the relation between the velocity of the magnet and all those things. So, what we will do is we will use a smaller magnet and move that in and see, we will measure the amount of induced voltage. So, we will roll a piece of paper just to make a pipe, that is just to get the magnet, insert that into the coil. So, that now it is easy to get the magnet through that, and on the screen you have to select from experiments, say the electromagnetic induction, choose that one, and another window pops up here, and your connections which you are supposed to make also is shown here. Now, you start scanning for the induced voltage and then drop the magnet slowly into this, and this you should repeat until you capture an induced voltage. Here you can see it has captured an induced voltage, and here you can see this amount of voltage, these peaks, they correspond to the velocity of the magnet, number of turns and the strength of the magnet. So, if you move it faster, you will find the induced voltage is much higher. Now, another way of exploring the same is to use a rotating magnet. See, the AC voltage, AC generators work on this principle. Like you will have either a rotating coil or a rotating magnetic field. So, in this case what we will do is we will take a magnet, and to rotate the magnet we use a DC motor. So, we have a DC motor here, and this DC motor, when you rotate this, the magnet will rotate. So, we will use this unit to power it. What we can do is we have a square wave generator here, and using this we can power the magnet. In fact, we are supposed to do that using another 1.5 volt cell, but it is also possible to use the square wave. Now, magnet is placed here. So, again coming back to the screen, I will set this square wave to 100 hertz, that is equivalent to providing some 2.5 volt DC to that. You can see that magnet is rotating now, and I am keeping near the coil near that. See here, and on the screen what you see is now the induced voltage. You can watch the screen. Now drag channel 1 to fit, and you see the induced voltage, the frequency is some 26.4 hertz. That means this magnet is rotating at a rotational speed of 26.4. So, what we have done now is we have seen the phenomenon of electromagnetic induction in different ways, by using a rotating magnet and by dropping a magnet into a coil. Now, we will see the phenomenon of movement of a conductor, or suppose say you place a conductor in a magnetic field and allow electricity to flow through that, then there will be a force on it, that it will move due to the magnetic field. So, we will try to explore that by using this coil. Like if you apply a voltage to this, this will become an electromagnet, and then it can attract another magnet. So, this is what we will try to explore. So, we will using this coil we will make an electromagnet and use another magnet to verify that whether it is acting as a magnet or not. For that purpose, let us connect this. We will remove this generator, AC DC motor, and connect this coil to square 1. And now what we should do is we will keep this here and try to apply some voltage to that. So, coming to the screen, from these experiments let us choose the driven pendulum experiment. So, driven pendulum, what we are trying to do is this frequency of this we will start changing, and we need to keep a magnet in front of this one, so that either this will attract or repel by this coil, this solenoid coil. So, this is a small magnet, we are suspending it on a piece of paper to make a pendulum, so that it can move when there is a force is applied by this. So, we will keep this here, and you can already see it is moving at 1 hertz and it applies a force. So, now I will start changing this frequency. Say now it is something like 2.3. So, you notice that at some frequency the amplitude of oscillation increases. So, we have to find out at what frequency that happens here. So, you can see that it goes with a large amplitude at something like 2.3 hertz. The reason is, for this pendulum's length, that coincides with the natural resonant frequency of this pendulum. So, what we have done is we have explored how we can make a magnet using a solenoid, and also the phenomenon of resonance using a pendulum. So, when they are driving, this coil was actually driving the pendulum, and when the driving frequency is coinciding with the resonant frequency of the pendulum, the amplitude goes up. And you can see that now it is high, and if I start increasing this velocity, this frequency again, see it just stops, because now it is 7 hertz, it is not able to move it. We have explored the phenomenon of electromagnetic induction by using the coil and a magnet, and we also saw how the solenoid can be converted into a magnet by passing a current through that, and the phenomenon of resonance using a pendulum.